This podcast is for the normal distribution. We're going to spend a few days on it. In class, we're going to do an investigation using a stopwatch, and we're going to see how accurately you can stop a stopwatch as close to 5 seconds as possible. And we are going to gather data, and we're going to look at the data, graph it, and then we're going to practice finding the mean, which is average, and the standard deviation of the class data. When we graph it, you'll discover that the shape of the graph looks something like this, and this is called the normal distribution. Now, something is normally distributed when it's this shape, where the average is right in the middle, and then it's symmetric about the mean, which means it has about the same amount of data on each side, and it looks something like this. We're going to be using this graph quite often, the normal distribution, so let's fill this in. Over here. Okay, so if it's normally distributed, here's the average. The first standard deviation away from the mean, we have about 34% of our data in each of these bins. 2 standard deviations away, each of these would contain about 13.5% of the data. And then if it's 3 standard deviations away from the mean, we've already used up about 99% of our data here, so each of these would contain about 2% of the data. So if something is normally distributed, the data will be pretty much distributed like this. If it's 1 standard deviation away, it's 34% of the data in each of these bins. If it's 2 standard deviations away, 13.5% of the data, and if it's 3 standard deviations away, it's about 2% of the data. So we're going to practice using that graph for the remaining problems. It says, draw and label a graph for the following situations. The weights of 1,000 children were recorded on their first birthdays. The weights are normally distributed with a mean, an average of 10.3 kilograms and a standard deviation of 1.6 kilograms. So if we sketch what this looks like, we'll draw our curve here. It's not very good. Draw it again. Okay, and then I'm going to draw the mean. And if it's 1 standard deviation away, here's what it will look like. 2 standard deviations away, it'll be right here. And 3 standard deviations away, it might be right here. Again, let's put in our percentages. So if it was 1 standard deviation away, that was 34%. If it was 2 standard deviations away, that was about 13.5% of the data. And then it was 2%. And then out here it's actually 0.05%, which we didn't put in the other graph. Okay, we know right here we have 1,000 children, a mean of 10.3, and a standard deviation is 1.6. Let's put that in. Here's our average, 1,000. And, oh, sorry, not 1,000. That's how many children we have. Our average is 10.3. Let's put that right here. And 1 standard deviation away, we're going to add 1.6 kilograms. So that would give us 11.9 kilograms. And the next one, if we add another 1.6 kilograms, that would be 13.5 kilograms. I should put my units. I'm not. Let's go the other way. We're going to subtract 1.6 kilograms. We will get 8.6 for this bar right here, and 7.1 right here. Okay. So here is our graph. Okay, questions about the graph then are on the next slide. So it's right next to this on your page. A, what is the probability that a randomly selected child will weigh less than 10 kilograms? So let's find 10 kilograms. It's about right here. And what we're going to do is we're going to add up all these percentages. Okay, so here's 10 kilograms. What percentage is below that? Add all of those up. Okay, and you can see, well, first of all, this is the mean, the average. So this is going to be about 50%. So we could actually add these all up, and we should get about 50%. So about 50% is under that mean, the average. If it's normally distributed. What is the probability that a randomly selected child will weigh between 8.7 kilograms and 11.9? So again, let's find that here. 8.7 is right here, 11.9. We would add up 34 plus 34. 68% of the data is within one standard deviation. So this is one standard deviation away in each direction, 68%. It says, how many of the 1,000 children would you expect to weigh between 8.3 kilograms and 12.3 kilograms? All right, so again, 8.3 and 12.3, we'll find those. 8.3 will be somewhere a little bit less than this, and 12.3 will be a little bit bigger. So still it's within that 68%, a little bit more. So we're going to say a little bit more, or about a little bit. So it'll be a little bit more than 68%. So if we want to find 68% of 1,000, in class we've talked about this before, of means multiply usually in math. So 60% of 1,000, we're going to take 0.68. We're going to multiply it by 1,000, and we'll get about 680 children are within that region. It's a little bit more, so you can say a little bit more than 680 children because we went a little to the left and a little to the right. We don't know how much more, but that's a good estimate. A little bit more than 680 children. Okay, and then the last question, which is kind of cut off, how many of the 1,000 children would you expect to weigh more than 8.7 kilograms? So again, let's go back. 8.7 is about right here. So we're going to add up all these percentages, or we could take 100% and subtract these three percentages. So if we add up 34%, 34, 13.5, 2, and 0.5, add all of those up to get the percentages. We'll do that first. So again, we're on D right here. If we add those up, it's about 84%. So 84% of 1,000, and that would be 840 students. Another way that we could have easily added up the 84% is, here's what we wanted. We know that this is half of the data because it's above the average, half of the data. So 0.5 or 50%, I should say 50%, plus the 34% right here. So that's another way we could have gotten the 84%, besides adding them all up individually. Okay. All right, one more example. The monthly incomes of 10,000 workers in Ghana are distributed normally. Suppose the mean monthly income is $1,250 and the standard deviation is $250. Draw and label a normal distribution graph for this data. Okay, so let's do that. Again, we'll do our normal curve. Okay, we'll put in the mean, we'll put in our standard deviations. One standard deviation away, 2, 3, should be a little more symmetric than that. All right, so here it is, 1,250. The standard deviation is 250, so we're going to add 250 in the upper direction, subtract 250 in the lower. So that would give us 1,500, 1,750, and this one right here would be 2,000. This one would be 1,000. This one would be 750. And this one over here would be 500. So there are the amounts, and let's put in the percentages. Remember, this is about 34%, 34%. I can't really squeeze in my percentages, so I'll just write it for this one. 13.5 to 0.05. 13.5 to 0.05. Okay, so there's the normal distribution for the graph. Let's answer the questions, and your assignment will be similar to this. A, how many workers earn more than $1,500 per month? Well, here's 1,500. We're going to add up 13.5, 2, and 0.05, so add those up. And that would give us about 15.5%. And it says how many? So we have to change it to a number, so it'd be 1,500 times 0.155, which would be 1,550. So 1,550 workers earn more than $1,500 per month? How many workers earn less than $750 per month? So let's find the $750. Here it is, 2.05% of the workers. Okay, so this would be 2.05%, about 2%. So how many, again, we have to multiply it, change it to a percent, 0.025 times the workers were 1,500 workers. I calculate that quickly, I didn't have that number. Let's see here. So 0.0205 times 1,500. It's about 30.775. Oh, did I type that in right? 0.02 times. Oh, it's 10,000. That's okay. So this shouldn't be 1,500. To get this, we did 10,000 workers per month. I apologize. So this shouldn't be 1,500. There's 10,000 workers, not 1,500. 1,500 is the salary. All right, so that would be about 0.0205 times 10,000. 205 workers. What percentage of the 10,000 workers earn between 500 and 1,700 a month? So this is percentage, so now we just have to add the percentage. So it was between 500 and 1,750. Okay, so we're going to add here to here, add all of these up right here. So this is 1,750. And 750 was right here. So really we have to add 13.5%, 34, 34, 13.5. So this would be 13, oops, I don't want the decimal. 13.5 plus 34 plus 34 plus 13.5. Do that real quick. It's about 95% of the people. Oh, and it's actually 500. I have to add 2% to that because here's 500, so I do want to add this 2%. So add 2 to that, so that would be 97%. So that's most of the workers. 97% earn between 500 and 1,750. And the last question, what percentage of workers earn less than 1,750 a month? Okay, so less than 1,750. Here's 1,750. It's everything less than that. So we could take 100% minus the 2.05% is probably what I would do. Minus 2.05. So about 97.95%. 97.95% or less than 1,750. So I've seen a couple types of problems. If I ask you how many, find your percentage and multiply by the total. If I say what percentage, just look at the normal distribution graph and you can figure out from there the percentages. So your assignment is more practice on this. Come with any questions tomorrow and we will spend a second day on normal distribution.